Hi friends, this is Ishan and today we are going to discuss about the clustering in MQ along with the distribution setup. In the last video I've discussed about the clustering, like how do we create a clusters and what object requires in a clustering, and what is a full repository queue manager, what is a partial repository queue manager. So we have created 4 queue managers in the last tutorial, in the last video, A, B, C and D, and we have created two queues for each queue managers. A and B we have defined as a partial repository, and C and D we have defined as a full repository queue manager. So also as per the IBM recommendations, we should create 2 full repository queue managers, and that queue manager should be placed in different nodes for a better or for a good availability. You can say a failover is achieved by this process. So this is full repository queue manager A, this is B, C and D. A and B are the full repository queue managers, and C and D are the partial repository queue managers. A will communicate to B, and B will communicate to A will communicate to B and B will communicate to A. In the same way, the communication will happen between A and B, and A to C and B to D. If you open MQ Explorer, you can see what are the objects defined for A, like listeners. So there are 2 queues, 2 channel. One is a receiver channel, that is 2.A, from where the application will take the messages, and one channel is 2.B, where the application will, the A queue manager will send the message to the B queue manager. In the same way, B, so channels is also there, or you can see the listener also. So listener is running A.LSTR, and if we go to the partial repository queue manager, so there was 2 queues and channels. So there are 2 channels, 2.A and 2.A. 2.A is the receiver channel from where the application will get the message, and 2.A is a cluster sender channel where the cluster will send the message to the A. In the same way, if you check the D, so there are 2 queues and there will be a 2. Don't consider E.D now. Okay, I will show. This is the basically I have created for the distribution setup. I will create again. So 2.B and 2.D are the channels, and if you go to listener, so there is one listener, D.LSTR, don't go there, D1.LSTR. So if you go to the clustering, so when you go to the queue managers cluster, if you open this one, so this is alpha we have created. And how do we create a queue manager as a partial a full repository? Like we will alter the attribute repos of the queue manager with the cluster name. So alpha we have created as a queue manager, cluster name, and 2 full repository queues and 2 partial repository queue managers. So A is a full repository queue manager. It will communicate, like you can see the arrow, right, from A to B, and it will communicate to A, so B to A. So C will communicate to E, you can see in the figure, so C to A, and you can see the clusters also, and D to A. So what I do, I will just put some messages again to show you the load balancing. Also the load balancing which we are doing here is a round robin load balancing. So this is A, right? So this is A. So we'll put some messages to A. I'm putting messages to first queue of the A queue manager. So I will put some messages, around 10 messages. I will put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, did 15 messages. 1, 2, 3, 4, So 50 messages I put here. So if we go to the queue manager, we can just run mqs control command. We can check the current depth of the Q1. So display Q local Q1. So 4 messages are there. So we have put in 15 messages, right? So in the same way, sorry. So if I get try to check the current depth of a Q local D1, sorry, Q1. So we have 3 messages here, and in the same way we will check here Q local 1 Q1 and the current depth. So 4 messages are there the same way, and if you see here Q1, and we will check the current depth. So 4 4 4 4 4 12 and 15. So 15 messages we have put in the from the queue manager A, and the load balancing is happening between all the cluster members. The load balancing is happening as per the round robin cluster algorithm. So if you want to get a message, you have a command amqs get to get the messages from a destination queue. If we check here also, we can see the messages. It's taking time. So see, in the AQ manager, in the local Q1, we have 4 messages. In the same way, for 3 here, okay, 4 here. To C is in C we have 3 messages, right? So C 3, and in the D we have 4 messages. Now, what I did like this. So we have created this one queue manager. So we have created a queue manager like this. Okay. So this is you can say A. We have created AQ manager. Okay, this is B. This is C, and this is D. So A is a partial repository. So it's a full repository. Now it's a partial, it's also a full repository. It's a partial repository, and D is also a partial repository. How do we create a full repository queue manager? As I said, we have to change the repos attribute of the queue manager. Okay, So here we have created two local queues, q1 and q2. Here we have created two queues called q1 and q2. In the same way we have created q1 and q2, and here also q1 and q2. The channel we have defined like 2 dot 2 dot a, which is the receiver channel, and here also 2 dot b, receiver channel. How do we make color? Okay, no problem. And here 2 dot c, sorry, 2 dot c as a receiver channel here to the. Now a will communicate to b, so we have created one sender channel which is called 2 dot b. So it's a sender, cluster sender channel, CLS, CLUS, SDR, SDR. So this is a cluster sender channel we have defined. B will communicate to A, so we have defined 2 dot A as a cluster sender channel. C will communicate to the B, sorry, D, A, so 2 dot A as a cluster sender channel, SDR, and here this is D, right? So D will communicate to B, so we have created like 2 dot B as a sender channel. It's not SDR, it's a cluster SDR. I'm just writing for the purpose. Anyway, yeah. So yeah, good now. So the communication is from, you can see, from this will communicate to this one in the same way. This will communicate to this one, and C will communicate to the A, and D will communicate to the A. Okay. So this is the cluster environment which we have set. Also we have defined some listeners. Here we have defined A dot LSTR. Okay. A dot LSTR. It's not visible, we have to make it small. Okay. And here we have defined B dot LSTR, LS, listener. Here we have defined C dot LSTR, and here we have defined D dot LSTR. The port number which we have given to AL is as per my memory, I have given like oh god, yeah. We can check in the console itself. So 3131 we have given to the A. So in the same way we can check here. 3232 we have given to B. So 3333 much per we have given to C, and okay. So the port number which we have defined is like this: 3131 here, 3232, 3333, and 343. Sorry, 3434. So this is the setup which we have discussed in the last video. Now what I'm going to do, this is a cluster, this is a cluster, okay, and I'm going to add another queue manager. which we will call C in the E. So what I'm going to do, I'm going to add one more queue manager which is not in a cluster. Okay, and then it will communicate to the C. It will send a message to the C. So the objects which we need in sender side, we are defining, for example, q, we are defining not q, m, q manager we are going to define, and m will communicate to C. Okay, and this is not in a cluster, so we need a remote queue, of course. Remote queue, and then you will send a channel, and here we need a listener. So here we will define a listener, list here, and the port number will give like 320 to the queue manager. And also we'll define a receiver channel for the C queue manager, which will communicate to the this one. So we will make the setup. Also we will define my XMIT queue also. XMIT queue. So we will create one queue manager which will communicate to the C. So what I do is start the configurations. Okay. So create a variable m. We will start the channel. Start the queue manager. Str. Okay. So yeah, the queue manager is up. So we will define the objects for queue manager m. So first we will define a remote or XMIT queue. So define queue local. It's communicate to C. So I'm giving a name as C, and usage. So we have defined one XMIT queue. If you want to check, we can check it. We can define, we can check the XMIT queue like display queue local C. So this is the queue name C, and you can see the usage. So in local queues we have two type of uses. One is called XMIT queue and which is called a normal. So if it's a normal, it's a normal queue, it is a local queue, and if it's a XMIT, so if you want to create a queue as XMIT queue, so we have to change the attribute usage on the queue level. So we will define a remote queue now. So define queue remote. We will give it the name as this is m dot, so m.rq, so our name So our name, we will want to connect. There are two queues. You can see there are two queues here, Q1 and Q2. So what I do, I will connect to the Q2 queue local. So Q2 RN name remote queue manager name, which is C, and you xmit queue, which is C. Okay. So some issues is there. Sorry, it's RQM, right? So we have created one remote queue. If you want to check the attributes, you can check the attributes of the remote queue also. So the command display queue remote and the name of the remote queue, so m.rq. Oh, sorry, m.rq. Oh fuck, we are given a wrong name, queue. So I created a queue manager queue as a name of queue only, not an issue. So this you can see the attributes of the queue, like this is the queue name, this is the scope of queue manager, then xmit queue is using the xmit queue. It will take the message from the application, it put the message of the application to the xmit queue and send the messages to the receiver channel. So next we define a channel. First send a channel, define channel name, like we are communicating to queues. Okay, we have given the name as a m or something, but we are created remote queue as a this one. Okay, so define channel m.c, channel type channel type is sender channel, str, and con name we have to give. We are using a local host. So, and the port number which we are using, it will send the messages, right? So we have chosen the port number as 3939, so we'll make it 3939 as a port number, and xmit queue, which is C or yeah, C. So channel started. So channel is created. You start a channel, start channel. m.c. So channel is started. Now see, channel is retrying. So because we have to define some of the objects on the CQ manager. So what I do, I go to the CQ manager and I will define some attributes. So now to communicate from C D to M to C, we will define one local queue is already defined. We will define one listener which will listen to the port number 3939, and also we will define one channel. So what I do, I just start defining the channel. So defines channel, we have given a name like envt, okay, and channel type CHL. It's a receiver channel RCVR. So channel created, we define one listener. We'll give it a name. We already have a listener called c.lstr. So what we will give it c1.lstr. TRP type TCP and port number, on which port number, so it's will be 2029. Sorry, 2029. Okay. Invalid. Define listener name c1.lstr. TRP type TCP and TRP type. Oh, sorry, it's defined that I've displayed here. Sorry. So started, we will start a channel c1.lstr. Start listener right. So started. So we will check the listener status. Display as status c1.lstr. So you can say it's a running. Okay, we can change the control also, like manual and QMGR. Manual is like one of the attribute of a listener. Like for example, control like when it specifies that how the channel will start it. If we define a QMGR, it means that whenever the queue manager is started, the channel, the listener will start it automatically. And if we give a manual, it means that when this queue manager started, we have to go to the channel and we have to start as a manual. Okay, so in real-time scenarios, basically the channel are defined as a QMGR. So everything is up and running. Okay, we can check here. So channel status is running now. What I do, I will get some messages from M to C. So QSC, sorry, AMQSPT. We have defined here q.rq and queue manager. So now the queue is open to put some messages. So I put some messages like hi, this is MQ clustering video. So if you want to check what is the current depth of queue in C, so display queue local, we have defined on Q2IS. We will check it. So 6 messages, 1, 2, 3, 4, 5, 6. If you want to get some messages, you can get the message like and AMQ SGT Q2 and this is C. So hi, this is MQ cluster audio. So in this way we can create a cluster also, and we can also create a distribution environment in the cluster environment. Now if I put the messages from A also, like for example I put some messages from A, own queue2 because so we are going to put 5 messages. 1 2 3 4 5. 5 messages we have put. We can go and check how many messages are there. Okay, what I do, I will start give the message from here also. So here we can put only 2 messages, so 1 and 2. So if you want to check how many messages I got retrieved, so see 1 and okay, it will make you confused, but it's better I have to put some alphabets here. A B C D E. So 5 messages I put from full repository queue which is A, and I will put some numerical values 1 2 3. So you can see the messages are getting this one. See it. So first message, okay, so D got, so A from even A transfers A B C D E. So D is received from to the CQ manager, and along with the what we have message from remote queue, which is in the MQ manager, also get received from the CQ manager. So friend, this is a video which is a combination of clustering environment and distribution setup. In the next video I will share that how can we create a dedicated queue in a clustering environment. We will create a dedicated queue in a cluster environment of C, and we will check when we put a message from M to C, then how the dedicated queues are handled by itself, the queue manager, and also we can load balance the dedicated queues to the other queue manager, which is A, B, and D. Till then, keep enjoying. Bye bye.